This is the solution to problem number 13 from section 7.4. Yeah, this integral we have in the denominator something of the form something squared plus something squared. And so we will make the substitution x equal 1/3 tangent of t. If we do that, then I can see over here, I can see that when I square 1/3 tangent of t, then the 1/3 will get squared, become 1/9, and cancel out with the 9 that's in front of the x. So this will result in 1 plus tangent squared t. So the whole reason for doing that is because we know the identity 1 plus tangent squared equals secant squared. So along with x equal 1/3 tangent t, we have to also make the substitution dx equal 1/3 secant squared t dt. So putting the guys in, we have dx on top, which is 1/3 secant squared t dt. And in the bottom, we have 1 plus 9x squared, which we already have verified is going to be 1 plus tangent squared of t, and that's to the 3/2 power. So I need to use the trig identity in the denominator. Again, if you don't use the trig identity, then you did something wrong, because there's no point doing this without the trig identity. So we know that 1 plus tangent squared is secant squared, and that's what will get raised to the 3/2 power. So having a perfect square to the 3/2 power is going to leave me with, I guess I'll go ahead and pull this 1/3. The 1/3 that's sitting here, we'll go ahead and pull that out in front. So I'll have secant squared over secant cubed. So we'll get lots of stuff canceling there, and we end up with 1 over secant. But the great thing about this problem is that 1 over secant is just cosine. Remember, secant is the reciprocal of cosine, so 1 over secant is just cosine of t. And cosine of t's antiderivative is sine of t. So this will be my antiderivative, but that is in terms of t, not x. And so I need to do one more step to get my final answer in terms of x. And that step is going to be from drawing my right triangle. I'll do that over here. I'll do that over here. Here's a right triangle with an angle t. And I want this right triangle to reflect my initial substitution, which is up here. It's x equals 1/3 tangent of t. And so that means, I'll just rewrite that down near the triangle. That means that 3x equal tangent of t. So in my picture, I need the opposite over hypotenuse to be equal to 3x. So that's the opposite, that's the hypotenuse. The opposite over adjacent is 3x. So 3x over 1 is tangent of t. In order to figure out what sine of t is, I would need opposite over hypotenuse. So to do that, I need to know what this hypotenuse is. So that'll just take a little bit of the Pythagorean theorem. The hypotenuse of that triangle is square root of 1 plus 9, square root of 1 plus 9x squared. And so the sine of t is the opposite over hypotenuse. So my 1/3 is still there, looking at this guy. My 1/3 is still there, and sine of t is 3x over square root of 1 plus 9x squared. And the 3's will cancel, and I end up with just x over the square root of 1 plus 9x squared. And of course, plus a constant. That's my final answer.